So we'll do final exam review again today, and we'll see the solutions to the final exam that I posted. So we'll do the solutions today. And before we do it, any questions, any consensus you reached regarding grading, curving, any questions about assignments, projects?
I posted two people posted
So two people, you have to come to consensus. Two people cannot decide. Everybody has to do it.
I suggest we take so we can vote on it today, right?
Maybe not today, maybe tomorrow, Monday. Let's give it some more time.
Okay.
What are the suggestions?
I suggest we just give it the highest grade, like making it the center of the normal distribution, and everyone within one standard deviation gets that grade.
Using normal take the highest grade. So that's what it does. The key means that's what it does.
It uses one standard deviation of all schools and then assigns them cutoff data. Really?
Yes, that is what that is the technique.
Oh wow.
That it does to do curving.
Oh, okay.
So that is fine. Then what is this proposal? Max grade are the two options.
I actually like that idea.
This is not possible. We cannot do that because this was promised at the beginning. Midterm and final exam. Oh, what?
Just restructuring the weight, basically.
The length of time to take midterm are the same. Well, this I can do. I can do 25-25. That I can do, but I cannot switch.
Oh, okay. What does it say? 25%.
It says that first it proposes that maybe since the average of midterm was quite high, make it 30% and then final was 20%. But the problem there is that since I have already said before that final is 30%, some people might have thought that okay, midterm is 20%, I won't do it well. I'll put more effort in final. So if I reduce the final grade, then that person who was thinking that maybe I'll put more effort in final and get a better grade will be disappointed. But I can do equal weight. I cannot switch the weights. So I can do equal weight, but then everybody has to agree that the equal weight. So we'll have a vote, but on Monday, not today. So let's give it more time.
My question for those equal weight is, will we have to shift something else to account for that?
No, because final plus midterm is 50. If 25-25 is same 50. So yeah, we'll wait for this. Everybody read this, think whether this is good or not, then we'll have a vote. If you have, in the meantime, if you have some other suggestion, you can give. There is another suggestion. And switch midterm, no, it's too much. Cannot do that. Okay, so we'll wait on this one. So let's start with this. I will do it here so that it becomes easier to upload. Anybody try to solve these problems? Ideally, I should wait for you to try, but there is no time. Okay, so let's try it here. So can you take 5 minutes to find out what will be the output of static scoping for this code? Take 5 minutes. So the code is here. So you have to find out the output for static scoping. and you consider it as pass by value. Anybody has answer?
0, 0, 121, 133.
Wait. One answer is what? 0. Then
0,
0,
121,
121,
and 133.
133. Okay. Yes.
I got 0, 0, 0, 11.
0, 0, 0, 11. Any other question? Answer? You had some answer?
First one.
Which one?
The first one.
121 and 133.
132.
What?
132.
Oh, that's supposed to be 132, my bad.
Which one?
The 133 should be 132.
132.
I missed.
And you have some other things? Anybody else have a different answer?
0, 0, 21, 30.
0, 0, 21, 32. Who all agrees with the first one? And this so 3. Who with the second one? 5, 6, 7. Who with the third one? There are more than 14 people in this class. So what about the others? You don't have any answers? What?
I'm too slow.
Let's so this is static scoping. So when you go int main and you make I equals 0, which I are you making 0? The global I. Fine. Then you call foo. In foo you access I. Which I do you access? The global. So you first print 0. Everybody agrees with 0. Then you go into inside that scope, you make int I. So this is a local variable. What is the scope of that I? Yes. So scope of I is from this brace to this brace and anything inside. Right? So if I is 42, if you come here, but now here in this scope you have defined a new I. So I is 2. So what is the scope of that I? Scope of that I is inside here. Right? Now you call foo. You go to this function. Which I? Global I, right? Why? Because when you go into this function foo, the scope of this I goes away. The scope of this I also goes away. So you access the global I. So global I became global I was already 0, so you print 0 again. So these two everybody agrees. Now you make I equals 100. Which I do you make 100? What? Or somebody was saying global? Okay. So you make I equals 100. This I becomes 100. That local I. Now the moment you break from the, or you come out of this scope, then what is the which I do you resolve to? 42. Yes. Now you come inside this scope. You are changing I. You are making I equals I plus 21. Which I? I equals 42. So this I, this local I became 63. Now you call the function foo. You want to print I. Which I do you print? The global I. What was the value of global I? 0. The value of global I was 0. So these three has to be 0. Then you come out of that scope. You lose. You didn't yet lose any I. Then you come out of the other scope as well. So you come out of this scope. You come out of this scope. This I is which I? The global I. I was previously 0. You add 11 to it. I became 11. Now you call foo. Which I is this? Global. And global I is 11. So you all put 11. So this is the correct answer. Does everybody understand why this is the correct answer?
So because you didn't set I to anything globally. So
Because
you
what?
You didn't set I to anything globally initially. Right?
I too? What? I cannot hear
You
you.
didn't initialize I to any value.
No, no.
So as soon as you initialize something, it just stays that.
As soon as I initialize, it's
So you didn't initialize I when you declared it global, right?
no.
Okay. So when you go into another scope and you initialize it, is that then?
No, that's not initialization. That's assignment.
Oh, okay. So
Right.
assign. When you assign it to something, and that assignment stays with the global I.
Depends upon the scope again. Right? It depends upon the scope. So at that line, in the first line, when you are doing I equals 0, you have to see which I are you making 0.
Okay.
So that resolves to the global scope. So you make global I 0. Now when we added 11 to it here, which I it resolves to?
It's the global.
It's the global I. So you add 11 to it. Everybody understands this? Okay, so if you understand this, now let's do dynamic scoping. What happens to dynamic scoping? Can you take like again? Let's give you 3 minutes. Use 3 minutes to do dynamic scoping. The first two problems in the final exam, I'll do it last because those are like midterm questions. So I might choose not to do them as well. If we have time, we'll do them. Anybody has any answer here?
0 to 121, 132.
Okay, so he says 0 to 121, 132. You had an answer? Same or different?
Different, 0 to 6311.
6311. Anybody else has any other answer? So who all agrees with the first one? And the second one? More hands. People vote one. So let's start doing this. So how do we do dynamic scoping? We have to make a symbol table for this. So whenever we first encounter int I, so this line, so int I we have to make a entry in the symbol table. So we say I, it's an int, and we don't know the value of it yet, right? Or actually this was not the format. The format that we used was this. Int I, and the value, and we have the line number, and the value is not known. The line number is 1. We might not use that line number, but let's have it. So yeah, whenever you call int, that's what happens. Then you go to that next line, foo. So there is another entry in the symbol table. So which is void, and it is foo. It is line number 2, right? And it just does not have any value. Then you go to int main. So you decide, okay, this is int main, does not take in any value. It's line number. Let's forget about line number. Now inside int main, you're accessing I equals 0. Now which I? Dynamic scoping, the rule is you search the symbol table, whichever comes first, right? So then that I, you resolve it to this I. So your symbol table changes now. It changes to what? So at line when at I equals 0, your symbol table becomes this. So there are still 3 entries in your symbol table. The first one is int I, line number, let's forget about it, 0, and then you have void 2, and you have int main. Okay. Then you come to foo. So you call foo. Now here, the scope, you are not getting out of scope yet. If it was curly brace, closed curly braces, then you would have gotten out of scope. But if you are calling foo, you didn't get out of scope. So you come inside foo I. Which I does it resolve to? The first one that you find in the symbol table. You found that, okay, the first one is this I. So you print 0. So the first value is 0. So this is correct. And this everybody got correct. So first value is 0. Then you return. You return from foo. Now luckily inside foo we don't have any local variables, so we are safe. So then you have a new scope. Now when you have a new scope, and inside the scope you are declaring that local variable int I equals 42, you have to have another symbol table, right? And we link it using arrow. So when you first, when you go to that line, so this is int I equals 42. This line, if you come to this line, your symbol table again changes. So now you have the previous ones in I, 0, void, 2, and in main. Now you have another symbol table, and in here you have a int I equals 42. Right? Now you enter another scope. And there also you again declare another variable. So this is int I equals 2. Right? So you have another variable here. Now you call foo. You didn't go out of scope. So foo does access I. Which I does it access?
It is
The first one in the symbol table. So that is 2, right? So you print 2. So the second one, one is also right. Everybody got it right. So second one is 2. Now we have problems with the third one. Some say it's 121, some say it's 63. Let's see. Now you make I equals 100. Which I do you make 100? If you make I equals 100, which one? The first one that you get from the symbol table, that is this 2. So this 2 becomes 100. So instead of 2, this now becomes 100. Now you release the scope, you get out of scope. So if you get out of scope, then this one you have to delete. You have to delete this entry, right? So if you delete this entry, then what happens? Your symbol table is now. So this you are going to the next line of code, I equals I plus 21. So here your symbol table looks like this. So you have an int I 0, then you have a void foo, then you have an int main, then you have an int I 42. You don't have that one. Now you do I equals I plus 21. Which one changes?
42.
Yes?
Int I equal to 42.
Yes, this one will change the closest one. So this one changes, this becomes I equals I plus 21. So this one becomes 63. Right? Now you call foo. If you call foo, which I does it resolve to? The first I that you can find in the symbol table resolves to 63. You print 63. So which one is 63? This one is right. 63. Everybody understands why it's 63? Then you again go out of scope. So if you go out of scope, you have to delete this one. Right? You have to delete this one. Oh, no. You don't have to delete this one. Because you just got out of scope and there you didn't have any local variables. Right? So you shouldn't delete this one. But then the thing is you get out of scope again. Right? So when you go out of scope here, then only you delete. If you get out of scope here, you don't need to delete because there is no local variable declared inside. So since this is the int I equals 42 was declared under this scope, so when you get out of scope, that gets deleted. Then I equals I plus 11, which I does it resolve to? This global I, right? So I now becomes 11. When you print foo, you get 11. So the last one, sorry.
The global I or the I equals 0, the main I?
Main, there is no main I. There is the global I, this one.
Well,
The only I that is in the symbol table.
I is 0, though, right?
Yes, but then you have to execute I equals I plus 11.
Okay.
So that makes it 11 and then you call foo. When you call foo, this is the only I in the symbol table. So then you use that. So this becomes 11 and you print 11. Okay, so everybody understands that problem, right? Any doubts in dynamic scoping, static scoping? Okay, so let's do the next one. So next one is again memory. How much time do we have? We have till 11:30. Okay, so then let's spend 5 minutes. You try to do this. Okay. Spend 5 minutes to do this. What do you have to do? Following C syntax. Oh, okay. The garbage, dangling references, and so on. So let's take 5 minutes to do location 1. Up to location 1. Let's do it. If you have an answer, you can just raise your hand. Then I'll stop the wait. You have an answer?
Yeah.
Okay, let's see your answer. So, can you draw? Can you tell us how to draw the box and circle?
Like
Or
step by
no.
step, or
Just give me the memory locations that are garbage at location 1.
at location 1. Well, C and star B point to null at that point. Well, actually, there's a garbage location because C gets memory allocated and then it gets freed later on, and B star pointed to that location too at the time. So
is that garbage?
garbage. What's the definition of garbage again?
Garbage means you did not deallocate.
Oh, it didn't
You
deal.
did not deallocate a memory, and you can't even point to it.
Oh, you can't even point to it. Okay, yeah, I don't think there's any garbage.
Okay, so let's start with the box and circle. Let's start with the box and circle diagram. So into this TDI. So this is which problem? Problem 4. So the moment I declare A, I have to have a box and circle for A. Then we declare B, so box and circle for B. Then we again declare C, so box and circle for C. we have, okay, no, memory alpha, beta, and delta. So alpha, beta, and delta. Now we have a malloc. So the moment we have malloc, we have to have a memory allocation in the heap, and this is address 1, right? And C is equal to int star malloc. So which means that C has to have the value 1, and C star points to the location 1.
So for you in stack, right? You do malloc, you allocate memory on the stack, right?
No, not stack. When you do malloc, it means you give memory in the heap.
Huh. I thought you were new. You allocate memory.
New and malloc are different. New is a Java concept. New class.
That's a C or C++?
What?
That's a C symbol.
C. Yes. Now this is C. So malloc, when we do malloc, you get allocated in heap. You don't get allocated in stack. Stack is for local variables. So C is in stack.
I'm sorry.
So do you know? So C, A, B, C, all these three are in stack.
This is not in main. Right? This is not in main.
No, this is in main.
It is in main.
Yes. So A, B, C are in stack, but that memory location 1, that is in heap. So because A, B, C are local, actually A is not in stack. Sorry, A is not in stack. A is in global memory, global data. So it's not a part of stack. B and C are in stack, but that memory location 1 is in heap. Do you understand this? This is an important issue that he raised. This you have to understand, and not for this problem, but for other problems, like when we do runtime execution. So A is not in stack. A is in global data, right? B and C are in stack because B and C are local variables. Now the memory that we had using malloc, that goes to heap. That does not go to stack. That goes to heap. So it's a good exercise to understand where which variable goes, right? Not needed for this problem, but needed for runtime execution. So everybody understands this step, right? So this pointer is star C. Now we do B equals malloc again. So then there is another memory location that should go to heap. And this is 2. And we said that B is equal to that. So that means this value becomes 2 and star B actually points here. Right? Then B is ampersand C. What happens? Yes.
Is it star B or star B?
No, star B. Right? Because that's the first location that B points to. So that's why it should be star B. Now it's a different issue if that memory location has another address. That is a different issue. We haven't gone there yet. We will go there. So now, okay. Where is star B now?
No.
Now. So we'll come to that as well later in this code. There is a concept of null pointer, right? And this is a different concept than void pointer. So null pointer is what? Every pointer type, whether it is a pointer to an integer, whether it's pointer to a character, string, does not matter. Every pointer type has a default value. The default value is null. So if you do not either you do not initialize it, or you just do not allocate memory to that pointer. You can choose it to be null pointer initially. Now again, so there are three concepts. First is initialization of a pointer, second is null pointer, and third is void pointer. Initialization of a pointer does not mean that it is null pointer, right? So if a pointer is not initialized, it does not mean that it goes to a null pointer. Null pointer is a reserved pointer kept for any type of pointers. So integer pointer has a specific type of null pointer. character pointer has a specific has a different type of null pointer. String pointer has a different type of null pointer. So when you do some pointer, say c equals null, as we did do there, right? C equals null, it gets assigned the null pointer. That is a reserved pointer. It's not like it is not initialized. If c equals null, that doesn't mean that c is not initialized. C is initialized to a null pointer, and this null pointer basically points to nothing. No, it doesn't point to an address. It's just a default value kept for integer type of pointers, right? So these concepts we didn't discuss these concepts, and you don't really need to succeed in the final exam, but these are good to know. Now there is another concept called void pointer. Void pointer is totally different concept than uninitialized pointer or null pointer. Void pointer means it points to a memory address location. It points to a very real memory address. So you have to do malloc. You have to do malloc to assign memory to that void pointer and initialize it. But you can cast that pointer to any type you want. You can make it int, you can make it character, you can make it string, right? So it's an abstract type. So that is a totally different concept from null pointer and uninitialized pointer. So these three concepts you might want to know when you are doing programming or when you are going for job interviews, right? They might ask you this type of questions. What is the difference between uninitialized pointer, null pointer, and void pointer? So that's important, but you don't need it for this course. So star B is what? It's not really the null pointer. It's just uninitialized star B. Now if you should make star B equals null, then that means star B points to a null pointer. Right? So that is a different case. So at this point star B is not initialized. Do you understand this? Okay. Now you do B equals ampersand C. So what happens?
The value of B becomes the memory location of C, which is
Exactly. So now everything changes. So since everything changes, you have it's better to rewrite the memory location. So we have A, 0, alpha, B. Now in the memory location, what do you have? You have ampersand C, which means you have delta here, right? The address of C. This address was beta. C was here. C did not change, so C had 1 delta. The memory location here was 1, and C was pointing to that memory location. Here we have memory location 2. B was actually pointing to that, but now it is not. Right? Now it is pointing to C. Right? So now star B points to the location of C. So star B has the value 1. Now star B, star C is same as star B. Right? Now star B gets a value. You had a question?
Actually, so star B doesn't get value until it gets reassigned.
Yes. It didn't have a value before, now it has. Now it has a value to associate with, although that value is uninitialized, so it will have garbage, but still it has a location, right? So that is what happens when you do A ampersand C. No, B equals ampersand C. Now you do A. So A again you have to have malloc. So now a third memory location is there in the heap, and you do what? A equals that. So 3 is the value of A, and star A points to this location. So this is star A. Now you did free C. If you do free C, then what does it mean?
it gets rid of the values well, it gets rid of C altogether, right?
So what happens? What happens when you do free C?
So it would get rid of the pointers.
Connection to one will
Or C, yeah.
Pardon? Connection to?
relocation one.
Okay.
Get cancelled.
And then anything happens? That's it. Nothing happens. Okay. So cancelled means what? This gets deallocated. Deallocated, and basically this value, no, this value remains. So if you do free C, then that means that memory location gets deallocated, and that value you don't tamper with anything. Now you did C equals null. So here comes the concept of null pointer. If you do C equals null, then this value becomes null. Right? This value becomes null. So this star C points to nothing. Nothing. It's not garbage. It's not garbage. Because this is nothing means it's a default value that is reserved for integer type of pointers. It's not garbage. So that is our location 1. So now what do we need to answer? Memory locations that are garbage at location 1. Which are garbage?
2.
Yes. 2 is garbage. You did not deallocate and you cannot access. So 2 is garbage. So garbage is 2. Okay. Then
So, and you always have.
location, yes,
So, no.
dangling references at location 1. Any dangling references?
I had a quick question. When we did the C equals null, wouldn't that get rid of the pointer to the deallocated memory as well?
Yes, yes, yes. These are all the other.
Gotcha.
No link. So are there any dangling references? So dangling references means what? You point to a deallocated memory. Yes.
If we hadn't done the C equals null, would the star C be a dangling reference?
Not star C, because star C won't point to anything. It is free. Free gets rid of dangling references.
Okay.
But star B. Star B would have been dangling reference. But now star B is not the dangling reference. Because it is pointing to something which is nothing, default value. But still it is pointing to something. It's not pointing to a deallocated memory location. It's pointing to a default value, nothing. Yes.
So the free frees up the heap memory and removes the reference, but it doesn't remove other references.
No. Unless you do free B star. No, you cannot do free B star. Unless you do free B.
Okay.
But we didn't do free B. So there are no dangling references.
So if you get free B, then it would deallocate.
Yes.
Even though B star or star B is not going to anything on heap, so it's still just free whatever B is.
So free means it will just remove the link. It will remove that link. So B star won't be any dangling reference. It won't be. So star B won't be dangling reference.
So when free is used, does the circle have nothing in it then? Like if when free C
No,
was
it does not change anything into the circle. It just removes the link and also deallocates that memory.
okay.
So now if somebody puts something in there, you cannot access it using star C. Star C is still deallocated. But if you do star B, then you'll get that value. Because star B becomes dangling. Right? But that is confusing us. So that is not the case here. Right? So don't talk about that because we will get confused. So that is location 1. So this is location 1. So now let's again redraw location 1 so that we are not confused. So we start from here. So, where we start? So A had, so there are these memory locations. One, then we have two, then we have three, and then there was A. Its location was alpha, it had 3. Then we had B. B's location was beta, and here it had delta. So we have C. C here we have null. C location is delta. B is still pointing to C. A is pointing to 3. Well, star A, star B. That's it. This is deallocated. This one is deallocated, and 2 is garbage. This is garbage. That's the scenario. Yes, there is that. So now let's start from here. We do index new variable. You have a question?
Yeah, why is that, the S? Where did it go from 2 to the S?
Yes.
Yeah, indeed.
That's the delta.
Yeah, whatever, why is that?
Delta. Yes.
Yeah, when did it change?
When did it change? Oh, okay. It changed here. So you mean you want to say that when did this became delta? Right? Okay. So it became delta when we did this line of code. B equals ampersand C. Okay. Any other doubts? Yes.
For this new section, before we talk about X, shouldn't we do something about C?
Oh yes, good point. Good point. Before we talk about X, we have to do scope resolution because we got out of scope. So when we get out of scope, then C, which one gets deallocated? C gets deallocated, right? So C gets deallocated. I missed that. So now star B is what? Dangling pointer. Star B is a dangling pointer, right? Because you deallocate C. Now you go to a new scope. So you have X. So since it's another variable, you put it into the stack and have a box and circle for it. And this is memory location kappa. Then you do A equals malloc. So now we have a memory location 4. You make star A equals that. So star A is this, right? 3, memory location 3. So in the value of memory location 3, you will have to have 4. That is what this does. Star A equals in star star malloc. So which means now this one points to this. So this is star star A. Everybody understands this? Any doubts? Okay. Then we go to the next line. X equals star A. So X equals star A. What was star A? Star A was 4. Right? Star A was 4. So if X is equal to star A, then we put 4 here. Now if we put 4 here, then that means star X is pointing towards 4. Fine. Right. Now you have star star A equals, you take ampersand A and make it a pointer, integer pointer. So star star A is what? Star star A, so this, and ampersand A is alpha. So basically you make it alpha and so this becomes star 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 A. Do you understand this? So you take the address and percent A and you make it a pointer. Yes.
So then why is it when you're actually writing it, why do you have to declare the type to be a double star? Or in this case,
You don't have to declare, which you just did.
you don't
And
have
you could have done it a different way.
to-
The result would be different. But you just did. And that is a fact that you did. And there's no reason to do that. Yeah.
So you took the address of A, you turned it to a pointer to an integer?
Yes.
Okay.
So now what happens here is that star 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 A is 8. Star A is 3. Star star A is 4. And again star 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 A is 8. So these are cyclical references. Yes.
If star A is location 3, why doesn't x equals star A pointer make x pointer location 3?
X equals star A. No, yeah, star A means you have to take the value of A.
You have to dereference it.
So value of A is what? Value at the location where star A points to. That's the semantics, right? So star A means you have to take that value where star A points to. So star A points to 3 and that value is 4. So when star A is used in the right hand side, that is the semantics. So remember, star A had two different semantics based on whether it was used in the left hand side or it was used in the right hand side. So if it is used in the right hand side, then you have to take the value at which star A is pointing to. So star A is pointing to 3, take the value of there. When it is put in the left hand side, then you take that location and you update the value in that location. So that's why when we did star star A equals in pointer star and percent A, then we took star star A and we updated this value. We did not update the location. We updated the value. Yes, yeah.
So I'm just confused why the address of A had to be turned to an integer pointer. Why
You could,
couldn't
you may not,
it could have just been integer.
Yes. you may not have turned into in star, but you did anyways. But the result doesn't change. So that is the case. Everybody understands this, or you have a doubt? Anybody has doubt? You can ask me question. Okay. So you try to understand. If you have questions, you can ask me next class. But let's move on. Now we go out of scope. If we go out of scope, what gets deallocated? X gets deallocated. So X gets deallocated, which means this. This gets deallocated. Now this is location 2. So this is location 2. Now we have to tell, we have to answer the following question. The memory locations that are garbage at location 2, which are garbage?
Nice.
What?
Well, did we count the ones from location 1 as well, or just the ones in location?
So one is deallocated, so that's not garbage.
No, I mean, do we count the garbage from location 1?
Yes, yes. Everything.
So 2.
2. 2 is garbage. Anything else? Nothing else is garbage, right? Okay. So then dangling references in location 2.
Star B.
What?
Star B.
Star B is dangling reference.
And
So dangling reference is star B.
and star X.
And
That would-
no, X is deallocated. So star X is not dangling. Yes? Star B is dangling and so is star B. What else is dangling?
Star B.
Star B is nowhere, that's right.
How would you get stuff from here?
So you used to point to 1.
Yeah, it's used to point to 1. Now star B, since star B is deallocated, and it still points to that deallocated location, star B also has a value that is deallocated. So that's why star B and star B both are dangling references. Are there any other dangling references? No other, I think. Then the memory locations that are deallocated in location 2, we have already identified. The C is deallocated, X is deallocated, and 1. Right? So that is the solution for this one. That's 15 points. So it's what 15 points. Okay, so you assimilate this solution and try to understand. If you have problems, you can ask me questions. But let's leave the questions to next class. Let's first solve it.
So for that, are we gonna post?
Yeah, we'll post this. But yeah, let's leave the questions to Monday. Unless you think that this is wrong. But let's move on. We'll discuss it. So this is problem 5. Let's not wait. We'll continue with problem 5. So this is type checking. So we have already provided you the abstract syntax tree of it. Now this is a function definition. Did we already do this? We did a different one. Yes? We did a different one. So let's replicate this. So fun, we have F, A, B, A, B, C, D. Then we have plus. So this is our expression plus. This is another plus expression. We have a array. Right? Inside an array we have a function. That function is the array name is D, and then the argument is the function apply. Right? Then it has A, B, C. So A is the function, B and C are the arguments. Then the plus has another array as the second argument or second operand. Then that second operand is also a function, and the input of that function is an array, and that array name is B, index is 0. Then we come to this plus. This plus has a string bar, right? So now we have to do type resolution. So for fun, since this is a function definition, we don't need type here. But this we need the type. So we need to have type. This is T1. So what we can do is we can say TA, TB, TC, TD, and it returns TE. Right? Let's say this is TF. This is TG. This is TH, I. It will be long one. It will be long one.
Would we have to do all those trees?
So that's what I'm wondering. Let's bypass this, right? Just bypass all these t's. If you do these t's, you'll be sure that you receive the correct answer. But let's try to just think about it, right? So the first one, we go to this node, right? We don't know anything about ABC. So let's give them general type. Now what we know is that TF is the output of class. So this type has to be same as the return type of function f. So the return type of function f should be TF. So what we know by parsing this node, what we know is the function f, the type of f is TA, TB, TC, TD, and it goes to TF. Right? That is what we know. So TE is same as TF. Now, if that is the case, plus, what is the constraint on plus? The constraint on plus is that the operands have to be of same type. So TH has to be equal to TG, right? And TF will be equal to TH and TG. So from there we know that TG equals TH equals TF. We have to have that, right? We have to have that. Now we come to this node, plus TG. Now if we come to this node TG, we know that TI and these two have to have the same type. So let's say TI and IJ. This is TJ, right? So we know that TI equals TJ equals TG equals TH equals TF. Right? We know all these. Now TI, D is an array, so D has to be, so let's just keep TF, right? Let's just only keep TF. So D has to be an array of TF, right? D has to be an array of TF. Now if D is an array of TF, the type of apply has to be int, because this is the argument of an array. The type of apply has to be an int. So A has to take B and C as input arguments and return an int, right? So the type of A is what? Type of A, so that means TA. TA is takes TB, TC and returns an int. We know that.
And that's because, where did you get that?
Because applies return type has to be int.
Where's that supposed to be?
Because D is an array. The constraint of array D is that the argument or the index has to be an integer.
Applying the index.
Yes, apply is the index. Right? So that the return type of apply has to be an int. So that's why TA is TB, TC and it goes to an int. Now we go to TJ. So we know that TJ has to be equal to TA. Now what is TJ? TJ, so C has to be an array. Is C an array? Yeah, C is an. So C has to be an array of, let's say this is TJ. So C has to be an array of TJ. So again, array of TA, right? TJ is equal to TA. So C has to be an array of TA. So we know that TC is basically an array of TA. We don't know anything about TB yet.
That's because of TG.
What?
TC has to be a type TF because of TG.
TC is an array of TA. Because TJ is TA.
What's TJ?
TJ.
The array.
Oh, that's TG. Oh, okay. Extra
TJ,
yeah, that's what I was saying. I thought it was G.
Okay.
Because of TJ. That's why it has to be like that.
Yes. So now see, since this is this is an argument, this is the index of C, so this has to be an int. So B, so you know from here that TB is basically an array of int. TB is an array of int, right? And you know that this is int, so that is fine. This is correct type. Now TH is a string, right? TH is a string. Then you know this, that this is a string.
You would do an arrow though, right?
What?
Would you do an arrow too, like you're doing with n, or would you say equal string?
Do not understand. What?
No.
No, what question?
I was gonna say, are you supposed to put equal string, or do you like do an arrow like? You
Oh,
did?
sorry. Yes. Yes. So then what? So we are done with all the nodes. So if you are done with all the nodes, let's let's redo the types here again. So what type did we have? So F is basically, did we resolve TA? TA is a function of TB, TC to int. So now we know TB is an array of int, TC is an array of string. So array of string, array of int, and it returns a value int, right? That is TA. Did we know TD? What is TD? It's an array of strings. So TD has to be an array of strings. So we know TA, we know TB, we know TC. So TC is also an array of strings. So we know TA,
TC,
TB, TC.
TC is an array
Oh,
of
yes.
string.
What?
Where's TC?
TC, array of TF.
Can you focus the camera a little bit? Yeah.
Focus.
Yeah.
Oh, sorry.
Yeah.
It's gone out of focus.
Okay. So that's TC. Or is TC, were you talking about the type of C or some TC?
TC is the type of C.
Type of C. Type of C is string.
Array of strings.
Doesn't it take type of B into it?
No, it's an array of TF. TC is the array of TF.
In TA, it should be array of int and array of string in reverse order.
Oh yes. So it has to be reversed. Okay, so let's redo it and make it clean. So what we have is TA. TA is, what is TA? TA is an array of int. It takes array of int. It then takes an array of string, and it outputs an integer, right? Yes, it outputs an integer. What is TB? TB is an array of int. TC. What is TC? Array of string.
So TC is taking NTB, right? It's input.
No, C is just array.
With B in it, right?
C is array.
C has this array with B inside of it, right?
It's not the type of B. It is int. It takes int as an input. Index.
C contains it. Or
No.
C does not contain B.
No. Why will C contain B? Because C is an array, and B is the index of that array.
Okay.
Right.
C is B.
Not B is the index. B0 is the index. So then what is TD? TD is an array of strings again. TCD. So TE is what? TE was TF, which is string. TF is a string. And so is all TH, TG, TI, TJ, right? So this is a TH, TG, TI, TI, and TJ. All are strings. Then that's it. So we have function f. So what is f? F is, it takes TA, TB, TC, TD. So f takes array of int, array of string, and give int as output. That's the first argument. So it takes a function as the first argument, then it takes an array of int, then it takes an array of string, another array of string, so TA, TB, TC, TD, and then it outputs TF, which is a string. What was D? Oh, array of string. So then I was thinking that there might be a typo, but no error. So that is the solution. So do you understand how to do with this one?
How to calculate the type of B?
Type of B. Okay, type of B we calculated using this node. So when we get this node, then we said that C is an array. So the index of C has to be an int. So this is an int.
Okay.
Right? So if this is an int, then B has to be an array of int.
Your parentheses are off.
Are they?
Yes. Unless I'm seeing something.
Oh, the last parenthesis. The last parenthesis. Does that make sense? Try to understand. If you have doubts, ask me questions. Oh, no, actually, it tells you to answer all this. Type that if returned. So here you should not write the entire if's type. Type that it returns. So return type you just write string here. Now the next problem we already did, so I'm not going to do it again. Lambda expression. Let's do it on Monday. Okay. Let's do it on Monday. If you have questions, I will come back in 5 minutes. Or